This is the chimney. You can see it's got moisture problems. We got a fireplace flue, and that flue goes down to the boiler. I think it's actually got a so that one goes to the boiler, and there's a wood boiler set up on it as well. So there's two on it, which is not cool, but we're gonna try to fix that. Yeah, so you can see this thing's all kind of, splitting apart. Everything's all kind of cracked up. This thing's done a lot of expanding over the years, and probably because that flue is there's no buffer between the flues and the brick wall, so it just pushes out and tries to expand. All right, this is what it looks like from the bottom. Yeah, it's just a little guy. It's still quite a bit of work, but you can see that this has some cracking in the back wall here right behind the firebox. So probably that firebox is built up against the back wall, and someone redid the brick here at one point. It's a different kind of brick. You can see the difference between the two. Probably just because it was deteriorating, because these washes, a lot of water comes down these edges, and I mean, you can see this one's all cracked up. So yeah, so we're gonna rip it down to this foundation, and you see how skinny this chimney is. There's really not enough room. There's only, you only got 2.5 brick, right? There's not enough room for everything. So we're actually gonna go out an extra half brick and probably just hang over that edge just a little bit to afford us enough room for all the internals. So it'll be bigger this way, and then these two edges will go plumb straight up. Okay, we're a couple feet down now, and it's still filled solid, but the moisture is just, I mean, it can't go anywhere. It's filled solid, so it's storing in here. There's no way for it to dry up. It actually dries really quick once the sun and the air hits it, but you can see every brick that I pop is like this. Like, just the very outside of it is dry, and then the rest of the brick is completely saturated. We're making good progress here. I just thought I'd stop at the smoke chamber and show you guys how this was built. You can see the back wall here. The brickwork was the back wall, and that's why we saw this cracking here against the back wall, and above where the flue was really tight. And this is just, cord 4-inch solid, this is just cord block, concrete block. It does have an airspace behind it, but obviously, we need 8 inches of solid masonry there, and there's only 4 inches. But this fireplace was used a lot. This woman uses this fireplace every day throughout the winter, and you can see, I mean, the plywood's clean. There's no charring. Shouldn't burn her house down. Wasn't the best maintained fireplace. They've got these really extreme corbels on here, which is typical. It's production brickwork, so they just use the cord brick that they use for the outside and just corbelled them. Really steep corbels too. Yeah, nothing smooth about it. This fireplace did smoke back into the house a little bit, so they had to put like a guard over the top of the fireplace, a little smoke guard, and then some doors on it to try to get it to work right. And this is the boiler flue, goes to the basement. And now you guys know, whenever you go to try to stuff a liner in and it goes to the basement around a fireplace, this is you see that steep angle there, and now you can see it on the outside. This is why you can't fit those liners down a lot of times. They don't want to go because the cross section changes here on the cut, and there's jagged edges, and you just get the liners don't want to make the turn because there's just so much friction. So there's a bend here, there's a bend there, and there might also be a bend right down at the foundation as well that goes that way and then straight down. So there's a lot of bends. So when you do these ones that go to the basement, they're trouble. So you got to know where to. You might have to open up the chimney to do it. If you're putting a liner inside of that flue. Okay, so we're down near the firebox, and obviously you can see now that this firebox is way too big. to serve that 13 by 13 flue. So that's one of the big reasons why it had problems drafting. And so they've got that smoke guard in there. Well, you can tell by how big the damper is. The firebox is even bigger on the inside than this opening. So if you can't see in there. Anyhow, brick, yeah, the brick's right up against the wood all the way around. So there's this layer of brick, and then there's an interior layer of brick. That's the facade of the fireplace inside, and the whole wall is bricked inside. So it's not connected though. This stuff isn't bonded into the masonry out here, which kind of makes it easier for us to build it back. But they do have another steel lintel in here. So that's the second steel lintel. The other one was up here, I think, because they're trying to corbel it so extreme. We did find some insulation here where they put the damper in, so that's a good thing to help prevent cracking. I think these dampers used to actually come with an insulation kit when you would buy a cast iron damper, and now they don't. The fire brick looks like they were made in Maryland. It's kind of cool little stamp on there. And we did end up finding one more turn on this flue going down. We were talking about, you know, maybe putting a stainless liner in it before if you wanted to go down this flue to the boiler. But now there's another turn that goes that way, and it goes that way a little bit, and then it goes perfectly plumb straight down. So there's several turns in these flues that go around these fireplaces, and it makes it really difficult to put the stainless liners in unless you're putting something small like a 4 or 5 inch liner in. I do think it's worth pointing out that this fireplace was used quite a bit, and if you look how it's built, everything's solid against the wood. And look at this damper. This damper is 6 inches away from that wood, and all that brickwork was right up against the wood here. And you know, you don't see any charring or any signs of you know, this house like almost burning down. So you know, I think it just speaks to like today's standards, how we build everything. You know, everything is, it seems to be way overkill, because you know, this is way inside today's tolerances, you know. All right guys, this is what the basement looks like. So this is the fireplace clean out, some block work in between the foundation, and this is the boiler, and this is the this is the furnace here. This is the furnace, and if you can see that pipe up there, originally they piped in, they've got 2 thimbles into that one flue on the side, the 8x12 flue, and this is actually like a wood burning setup, so a wood boiler, or a wood furnace, I mean. And yeah, so it's just a, I guess you call it forced hot air wood burner. And they try to use this when the power went out for a couple days, but they said it smoked back in the house. But then I found this inline damper that they never knew to open, so that might have been the reason. Anyhow, they just wanted to try to, they don't know how to use it. I honestly don't really know how to use it either, but we're going to try to get this operational in case the power does go out. I mean, it looks pretty much like a new unit, good backup anyway, but we're not going to go into the same flue here. So what I've got to try to do is get this pipe over, I'll try to pipe it over this way and get it over here somewhere. And then so we'll have a stainless liner that comes down for that one, and then a stainless liner that goes down for that one. The other thing I noticed is, look at the daylight coming through there. So we've demoed the back of the chimney. This is why you don't use 4-inch cord block or any kind of cord block on a chimney, right? They've just laid them on their side, and we're wondering where all the mice have been getting in. But when you leave holes like that, there's, you know, they get right into the chimney and they drag all this insulation. So they had nests all over the inside of that chimney. And not only was there mice in there, but there was snakes in there too. There was a bunch of snake skins, you know, small snakes, but yeah, just use solid block, people. It doesn't cost that much more to use a 4-inch solid block, you know. Okay, this is where we are outside. We just got done, we just finished cutting the foundation, so we cut that so it's level all the way around. It was pretty jagged, so we didn't want to have to put it like a massive bed of mortar just to get started on, so I just cut it, and now we're working on jackhammering some of these high spots off. And this is the opposite side of that wall we were just looking at inside, and you can see there's a lot of debris that's been put in here over the years. This would be the center of where the firebox was, and you can see the ash dump. There's a good pile of debris here on this side, so probably have to get down there and start cleaning out some of that stuff, and then figure out where where I'm going to put my thimble hole and clean out hole for this liner over here. Okay, a little update. We're get the siding all cut out and got some brick molding on. Got all our heights marked for the brickwork on both sides. Now I'm just working on cleaning this up. I just cleaned all the loose mortar off that was squeezing out the back. Actually, not loose mortar, but just the mortar was squeezing out the back. And now I'm just going to grind this with my cup wheel on the grinder to get back to some fresh brickwork. Probably parge the brick here. There's a lot to process down here. A lot of troubleshooting. So this is where the oiled fired appliance goes, or was going, and then the wood fire was up here. And then you see this gas line right above it. Obviously not really cool. So originally I was thinking, I'm like, oh, I'll just, vent this over here. I'll put a new flue in on this side for the wood burning appliance. You really got to be on each side to get around the fireplace that's in the middle, because everything's got to shoot, way to the left, way to the right, out of the way. But what I didn't realize is that I completely overlooked is over here. We've got this oil tank right here, which is not very typical to have an oil tank real close to the chimney like this. But anyhow, this is where I was planning on putting that thimble for the wood appliance. But obviously it's too close to the oil tank now. So I got a call into the inspector. He's going to come out tomorrow, hopefully, for an inspection when I do the concrete pour. So I just want to get the dimension off of that tank, whatever I need. I think it's 3 feet, but I'm not certain. So I've got from the tank over to that side, I've got, almost 5 feet. A little, it's 4 foot something. So what I'm thinking about doing is just routing this wood-fired appliance, and it's going to come by here and go into this block here. So look, it's going to be a little lower, right? And then hopefully we'll have clearance from the oil tank over there. And then this one, I'm going to, instead of running it straight in right there, I'm going to run it over to here at an angle. And so, that's the plan right now. Obviously subject to change after I talk to the inspector. I guess worst case, they might have to move that tank a little bit, which doesn't look like it'd be a huge deal. Got the brickwork going. Just getting ready to pour some concrete in a little bit here, but you see I had to corbel out here to get to a decent dimension. It probably will, it looks fine. Maybe somebody will think it's decorative, but I don't know. I've got my brick vent for the air, and I still have to join around it, but this goes into it's going to go into this stainless pipe here, and then I'm going to make that, it's not permanent, I just got that in there temporarily right now, and then I've got to make a smooth transition into the vent here. But the wire lath isn't in there permanent yet, just got to do a little bit more work. I got to cut this out here for the flue on this side, same on that side, do some block work here, and then I'm going to pour this with concrete. I'm only actually going to come up to, I don't know, probably like this level here, but I'm going to do 2 different pours. I'm going to do that pour, And then I'm going to try to figure out something for my combustion air, as far as like a flap or a switch or something. I'm not sure how I'm going to do it yet, but I just want to be able to close the air off to it. Because this is coming into I wanted it to come into the center of the firebox this time. So I'm just going to try this and see what I can come up with. I'm going to pin some rebar in to the existing slab. It's going to go in this way as well. Pour that over the top, and then I'll have a nice flat surface to start on. I'm going to figure out, this vent here, or sorry, the combustion air. Then I can build with masonry around it off of the new concrete, right? And then I'll pour another slab that will go into these hollow blocks, and I'll send some rebar into those blocks too. So obviously, building on top of a hollow block is not a good idea. So I'll get rebar in there. I'll pour a slab over the top of that, and that slab will probably come to I suppose like right around this height here. And I'll put rebar and reinforce that too, and then I'll be able to start my firebox on top of that. Bro, I just went to lay this brick without looking, and I looked at it, my hand was holding it next to a snake, and I almost lost it. I was just like, it's just a little baby garter snake, right? Dude, I haven't had heebie-jeebies like that in so long. Oh my God. I think he's actually stuck in there. Dude, my hand was right behind his head, and then when I looked, I was like, ooh! It's just like human instinct, What in the world? What are you doing in there, dude? You can't get out of that. You're not going in the house. Come on. Smarten up. Oh, dude, on my brick? Disgusting. Get out of here. Oh, that stinks. Dude, what in the world? Okay, I'm going to give you a little rundown here. So this is the flue for the oil-fired furnace. This is going to be the flue for the wood boiler. Obviously these are stainless liners, so they'll go in after the chimney's built. I was trying to make everything smooth and tapered so the liners will go down nice and easy. This one's got insulation, so it's got to be extra smooth and big. Got a little bit more work to do to smooth out some of that stuff, especially like this wire lath here that I ended up cutting out. Have to just parge over that. This is my outside air that you're looking at there, and it's going to come up centered in the firebox floor right here. This is the vent for it, and I always try to brainstorm to come up with new ways to do this, because I hate the kits that they sell in the stores, and it's just never any good way to do it. So I'm going to try to get this one to come up centered, because the natural flow of the air wants to be from here up. So yeah, this is what I come up with. I just kind of made this little door here that connects to that 4-inch pipe. It's just a piece of scrap stainless liner I had, and same with that piece of metal there. I just kind of bent, cut it and bent it, and basically this was a extra piece that I had. I went to a rain cap, a top mount style rain cap, and instead of the mesh on the side, I had them plate one side of it because of the prevailing wind direction. So I had just they put 2 of them on there and they weren't supposed to, so I had an extra one. It's got a nice little hinge on it, so I bolted the hinge into the concrete, and that was going to be my little flapper. And then I'm going to have to just go get something from the hardware store, drill the hole through there to kind of connect that, so it can lift it from the firebox floor and just kind of hold it open. So I don't know, I'm just trying to come up with stuff on the fly. It seems like that's going to work pretty good. I think eventually I'll come up with a better way to do it, or maybe I'll be able to order something from somebody that's better, but just how I'm going to do this one. So yeah, and then I'm going to use the rest of this plate here to, well, I've got this wrapped here. This block just wrapped, so the concrete will get poured right up around that. And then I'll have that nice opening when I pull this block out. And then this plate, I'm gonna just kind of put that up like that. And then all this is gonna get concrete poured over the top of it. I'm trying to get this firebox laid out, and it's not going very good. I can't really do what I want to do with it, but just having a lot of trouble, and all of it really has to do with that header height right there. You know, these, when they frame these houses, they just slam in these headers so low that you can't do anything with, like, that's why they had to have the masonry against the wood when they came through, because, you know, the masons showed up and the header's so low. The header right here is at 53 inches from the floor inside, which isn't enough. And then on top of that, which made it worse, is they have the raised hearth off the floor too. So, you know, the mason shows up and all of a sudden, oh, I'll go with the raised hearth, and then you have that much less room to get what you need done by the time you get to this height. So the clearances are really challenging. I've got my mark here, which is 8 inches from the lintel height, which is the minimum that I could be before I have to set this damper. So I'm trying to just figure out what I can do to get my clearances from this wood, because I can't build right back up against it. You know, this thing has to pass an inspection, not like when these guys built it. So I'm trying to figure it out, and I can't get the typical 8 inches of solid masonry between here and here, 8 inches plus 1 inch of airspace. I can't do that. There's just not enough room. So I'm making this firebox way deeper than I want to try to get this damper back away. So I'm at 22 inches deep right now, which is really deep. For this type of firebox, I'm about 40 inches wide at the face on the inside and 22 inches deep. Typically they start out about 20 inches deep, and you know, the deeper they go, the less heat you get back in the house, which is unfortunate. I do have room to come deeper here because we need 8 inches of solid masonry on the back side. I could come back more. I don't really want to come back too much more. So I got to be creative and figure out what I can do to make this work. So basically means I got to try to use all the tricks I can to make this compliant. I could do, there's not quite enough room here to do, well, actually, if I go from here, it's hard to do all this one-handed, but if I do that, it's almost 6 inches there. So I could be 6 inches thick as long as I use the lining of fire brick or like a clay flue liner piece there, like vitrified clay. I could be 6 inches thick, but I still need a minimum of 1 inch of airspace against this wood. So that kind of doesn't work like that either. So the one thing that I think that I can make work is that I go a minimum of 4 inches thick with 1 inch of like a Formula 51 mix on the inside of all the brickwork. So then that provides zero clearance. So it's been tested for zero clearance up against wood. So it means your masonry could be against wood if you have 1 inch thick of that Formula 51. Or, other smoke chamber mixes are the same way. But what I'm going to try to do is, let me see this, is still get my 4 inches thick with and still try to maintain 1 inch air gap. So I'll be 4 inches thick, 1 inch air gap against the wood, and then on the inside of that will be 1 inch thick of the prior fire Formula 51. And then still I'll have my 1/2 inch insulation blanket here, which is obviously really going to fireproof it through this area. But now I've got this damper back so far that, I have this problem here to solve the gap, right? So that gap is actually going to be filled with some castable refractory, and I'll come right from this bottom edge of the lintel here, right here, and I'm going to just roll that right into this spot on the damper. Not the outside, but the inside edge, so it's going to be just like a smooth roll. So I'll just form that up, and I'll put some rebar in it, and pour some bags of castable refractory so I can bridge all that and have a smooth roll. And it'll be more like a Rumford style design with that roll, the smooth roll in, from the breast into the damper. Unfortunately, I couldn't use a Rumford style damper on this. It just doesn't work. I did get a Rumford style damper for this, and I just can't use it because I can't get away from the wood fast enough with it. And this one, it angles like that and gets away from the house for me. So, and part of the problem too is this brick is 4 inches into the house. If the brickwork was flush with the drywall inside, I would be able to get everything back a little bit more too. So I don't know. There's just a lot of problems I'm trying to solve here. I can't even start building until I figure this out, because the inspector is going to show up today or tomorrow and take a look at this thing, and just I got to be able to know exactly what I'm going to tell them to get around these problems. Okay, here's a look at the progress. That's what the firebox is looking like. Here's the outside air. You just jointed this stuff up and sponged it off. And this is what it's looking like outside. Okay. Alright, I got this firebox done, and I was just trying to get creative to make this all work with the small amount of clearance we have to this header here. So this is what I came up with, and it's gonna work, but it took a lot of thinking to get to this point. So I've got my damper, and this is just a conventional style damper. It's not like the gasketed Rumford damper like you've seen me use on some of the other fireplaces, but so yeah, what I had to do was, typically you see these back walls on these fireplaces start to angle in at the top, and really the only reason they angle in, people will tell you it's to throw heat or whatever, but it's to angle in to get the firebox small enough to get to this damper size. That's why they angle in. So usually my damper would be up front, right, on that side, but because of the wood that's right here, it can't be on that side, so I'm keeping it to the back. So this one's going to have some of the Rumford principles to it. It's like a conventional firebox with some of the Rumford principles. I would have liked to splay these walls a little bit more, get a little wider, but I just couldn't. But the straight back wall, any Rumford fireplace is going to have a back wall that's perfectly plumb, which is the best way to do it. And so the other thing that I'm going to do here is I've got this piece of cork underlayment, just something I had on the job. I was using it inside to walk back and forth on. And I'm going to make this, this is going to be my form to make from the back of that lintel to roll perfectly into this damper, to taper that firebox into my damper out the back. Otherwise, you couldn't really make one of these dampers work on the back of the firebox. It just doesn't, there's no way to really taper it in there. So I'm going to roll that right in there. And to do that, I'm actually going to use some, I've got some stainless wire that I'm going to use in there with some rebar and some castable refractory mortar, or refractory cement, however you want to call it. Anyhow, this is the Heat Cast 40. The minimum thickness is 1.5 to 2 inches, so we're definitely going to have more than that. And I think this is 2500 degree stuff. I don't see it at the moment, but high duty gas roll up. Gas. Oh, maybe it doesn't say. Oh, got it right at the top. 2500 degrees. Here you are. So it's good stuff. It's really expensive. I think that stuff's like close to $70 a bag for 40 pounds, which is absurd, but whatever. That's what I'm going to use to get me out of this mess. And so this cork underlayment on this side, this is just stuff I had extra at my house from when I did the floors. So it's smooth on this side, so I expect it's going to release pretty easy when I go to pull it out tomorrow. I'm actually not even going to use this damper when I'm pouring it. I've got that angle iron that I'm going to set across there, and then I'm just going to weight the back side of this to hold it. I don't think it's going to be a lot of weight, so I don't really expect it to put too much pressure on this form. Like I said, I got this pinched in there with the 2x4 under the lintel with two legs just kicked up real tight, so that's in there pretty tight. And then this side, I'm just going to fold it over that angle iron and weight it down with some block. Alright, so I started pouring this stuff. Just placed my first piece of rebar in there. I'm probably going to do another piece of rebar when I get higher towards the back here. And then that stainless mesh that's right there near the top. And I'll bridge it over this fire brick here probably. And I expect with weight, this form will just kind of round out a little bit, and I'm okay with that rather than being perfectly flat. It actually would be nice if it did round just a little bit, you know. All right, gonna keep going. Okay, so I've got my second piece of rebar towards the back in. I added more of this heat cast 40, and now I got my stainless wire on top. I'm just gonna feather that in and fill up the rest of the way, flatten it off, and then that should leave me a nice flat place to place my damper tomorrow. So I just pulled my makeshift form out of here, and I'm actually really impressed with how this came out. Really nice and round. It does have some pock marks in it, but they're really not that bad, you know, but I probably could have, you know, vibrated it a little bit, and maybe I would have got the rest of those pock marks out, but it's actually really, really smooth transition. Pretty happy about that. Okay, so look, I'm gonna pull this right there, and look at that edge it's smooth right into that damper. How cool is that? We got our inspection today. Inspector came out. He likes everything we're doing. Explained to him everything we're using, everything we're doing. The cast in place refractory with the damper. Clearances from here, where you're going to use fire brick up here to get less of a clearance. He was pretty receptive to everything. He seemed like a pretty smart guy. And I don't know, you know, he doesn't inspect a lot of fireplaces because there's not a lot of fireplaces built anymore, but he seemed to you know, be into it. So he wasn't one of the guys that just stands on the ground and doesn't try to understand what's going on. I've transitioned these channels into just squares, and this one over here is a little bit bigger for the liners to come through. I got the insulation around the firebox like I've been doing. Just gonna offer the firebox a little bit of relief so it can expand without cracking everything around it. And yeah, so tomorrow I'm gonna come in, put some more insulation up, get this brickwork built up a little higher, and then get that smoke chamber done. All right, I'll give you a quick peek at what's going on here. We're at the smoke chamber now, and just got my partition wall going across here for each flue. and just started building that back wall over. I've got this damper set in place. I don't think you were here when I don't think I showed you this. So I wrapped this insulation up and around the whole firebox and set the damper on top of that. And then I'm actually out of the ceramic wool insulation that I typically use, so I use some rock wool around this damper. Just to, that damper is going to need some room for expansion, so this rock wool's really good stuff too. It's pretty fireproof. I don't know how fireproof it is, but I can't catch it on fire and I can't get anything to heat through it, so I know it's really good. And they've been using it for dampers for years. Yeah, so I've got plenty of clearance here now. You see this is my 1-inch buffer, my air gap between the house and the masonry, and I just kind of keep moving that up as I go. I'm trying to get that brickwork straight through at some point, but I just got to get this smoke chamber going. I'm using fire brick just in this one area to get my clearances down. Some of you might know, but if you use fire brick as a lining to your smoke chamber, you can get down to 6 inches thick instead of 8 inches. So it'll be 6 inch plus 1 inch air gap. This one's a little overkill because I'm using a lot of fire brick, and as you can see, I got plenty of clearance here. And then also on the inside of this, we're going to have everything's going to be parged up with the Formula 51 mix. So the Formula 50, all this stuff is actually kind of irrelevant and overkill because the Formula 51 is designed to be for 4 inches of brickwork to be right up against the building. Here's a little peek at the smoke chamber. Just getting, well, it's to final height, and as you can see, I'm just kind of rounding off these corners here. It was a rectangle, and the problem is, I've got a rectangle and I'm putting a round liner in. And to get this liner to fit inside of the dimensions that I needed to go with here, I've got to just ovalize the bottom of it a little bit. Just because of my thicknesses, I've used fire brick on the lining on both sides, and I've got to be a minimum of 6 inches of thickness on both sides, and then 6 inches plus the 1 inch air gap on the back side here. So I'm just ovalizing the liner a little bit, and then of course above here it doesn't have to be ovalized because I don't have to my minimum thickness, I only need the 4 inches of brickwork and blockwork there, and then I'll have a divider wall on either side of this liner when it comes in. And so I just grabbed a scrap piece of pipe that I've had kicking around my yard forever, and this one's a 12-inch diameter, and I just ovalized the bottom so I could figure out a rough shape to end this smoke chamber and then start to ovalize that around. Yeah, so I've tapered these back walls. I guess I've tapered these walls into the back wall, and just so the liner slides down nice and smooth. I didn't really feel like I needed to keep building that other partition the whole way. I think that this is fine to do it like that, and then so I'll have a partition wall here, here, and there. Alright, I've got all my my stainless product today. Whole bunch of parts and insulation and stuff, but so this liner is a 12-inch round liner, and I got the 12-inch bottom plate for it, and that's how you usually connect it to the smoke chamber. But so I didn't know when I ordered this stuff a couple weeks back that I was going to need to ovalize the bottom. So I would have had them do it at the factory, just ovalize it and then send me an oval bottom plate, but I didn't know, so I'm gonna have to do it myself and see how it comes out. I've got my ovalizer ready to go. We're gonna give it a shot. Okay, so I've got it pinched in here, and what I'm going to do now to try to get this oval is I'm going to cut either side and get, cut into that ring a little bit just to give it some relief so it can squash. Okay, I'll give you a peek at the smoke chamber. So I've got this, hold on a second. Yeah, so I got this all parged up with the Formula 51. And you can see it's pretty thick, especially on that wall right there. So I've got this bottom plate here, and it's just got that wire mesh on it. You can actually see a piece of it here. And I just bent that to fit in here. And now, so I mean, this is the rough smoke chamber, so I just let it sit up. It's still soft here, but harder. It's still pretty soft. I got to sponge all that up now. I'll give it a few minutes though. It still has to set up more. It's better to sponge it when it sets up a little bit. So this is nicely ovalized, and my liner's ovalized. So the liner will slip down inside of this, and I'm mudding up onto the inside of this metal bottom plate here. So what happens is when I put my liner in, it's going to kind of squish all that stuff out. I'll even build it up more before I put it in. And then from the bottom, I'm going to have to go into the fireplace. I can reach the bottom here right now. It's not terribly deep. It's probably 30 inches deep or so. And so I can reach the bottom and make all that nice and smooth and sponge it up. And then I'm going to put my liner in through the top here, and it will squish some of this Formula 51 out, and I'll be able to just smooth parge it into the liner. So everything's nice, smooth transition into the liner. This is going to be my divider wall for the fireplace flue. And so now when that liner goes in, I'm going to put this Premier Mix around it. It's the same thing as Thermix or any other kind of poured in insulation. It's just lightweight cementitious insulation that I'll put around it. And so I'll have the liner, and my insulation on the liner will start up a little higher than this spot here, up here a little bit. And then I'll keep going with my divider wall, and I'll pour a nice block of that Premier Mix in there. And then eventually, after this stainless liner's in there, I will probably start to move this divider wall in closer to it. So it'll be really close to touching the insulation on the liner on both sides. So I just gave that a quick sponge down in there. You can see it's nice and smooth. The corners are smooth. Everything's going to be nice and smooth tapered right into this liner. And now I am getting ready to go drag that liner over here and put it on. And once it's on, I'll finish smoothing everything out from the inside. Okay, so I've just got this liner in. It's a little bit of a chore, but I got it propped up there, and I'm just going to go take a look from the bottom and see how it's sitting. It's got just a band clamp holding it, so we'll make sure it's situated down there right, and see if I can parge it up into there nice and smooth. I didn't really like how it was sitting inside, so I just added a bunch more mix around the side here, and I'm going to reinstall this liner to it. It's a lot easier for me to do it from out here rather than try to reach up from the damper and add a bunch of mix up there. So this is a much easier way to do it. So I'm gonna plug this thing back in, clamp it down, and see if that'll work. Okay, this is the second attempt, and it's looking a lot better here. I should be able to reach up and take care of that, no problem. This is the Premier Mix, the lightweight insulation that I'm going to use around that liner. You can see it's like super lightweight. It's got some, I'm guessing, I don't think it says what it has in it, but it looks like it's got like really finely graded perlite, maybe vermiculite, and some Portland cement as a binder. That's what my guess would be. So I've just poured the Premier Mix, and you can see how that's going to really make a nice connection. And so one of the things about the Premier Mix is it's really lightweight stuff, and it allows me to be able to pour this solid around here against the block, against the brick, and not have to worry so much about the expansion from this liner. It's really low PSI mix when it dries, and this liner, when it heats up, is going to want to expand, right? Normally, say if you would fill that with mortar or concrete, that would crack, and then it would crack the brickwork, would crack the blockwork on the other side. So that's why we use this Premier Mix, or there's other companies that make mixes like this, same thing. Thermix is the same thing, and so it allows that stainless liner to expand. And so now my insulation wrap will come down to here. It will come all the way down. This liner will be insulated the whole way, and the liner, when it's insulated like that, will be rated for 0 clearance. So basically means 4 inches of masonry. Bro, what are you doing here? Up against wood. So obviously we have our 1 inch air gap still. So we are overkill. Here we go. Nice smooth transition into that liner. All right, so this is next day after this insulation has had time to dry, and I just want to show you guys what kind of what it looks like. So basically, it's hardened up, but still, with the trowel, you can just kind of, do you see how it's real soft like that? So that's really going to allow for expansion when this liner heats up and decides to expand. That's why we use this instead of mortar or concrete. So I've got this insulation, and I just cut it to a manageable size that I can deal with by myself. So I just cut it to 4 feet and got it going in there. And I slid it down as far as I could to that Premier Mix that was set up already, that I showed you just a bit earlier. And then I've poured some more Premier Mix up and around all this. That's just how I've kind of always done it. I put the insulation wrap on, and then I pour the Premier Mix up a little higher. So now I know I've got a perfectly sealed system there. And yeah, and just as I go by myself, so I don't have to try to handle this whole roll of insulation, I'm just going to cut it in sections and slide it down and then tape it around every time. At some point, when I get a little bit higher, I'm going to have to get this liner going straight up and down. I've got it straight just for this section here, but I've got it bent over my scaffolding for now because I've got the plastic over the top that I'm really going to need because of the rain coming. But I can build the brickwork up to here, and then I'll try to straighten that whole thing out. Okay, just coming up to the roof here, and I had to get this metal roof cut back and bent out of the way, so I was able to bend up a little bit here. And I have a guy that's going to bend me up a flashing piece out of the same type of material that will go on over top of this, and then out of the chimney will be lead flashing. So I'm just going to continue up right now with the block work, and it'll step, and then I'll start tying in this brick as it comes through the roof, and the brick will start turning and running the backside. Okay, I'm up above the roof now, and you can see how I kind of stepped that block work through, and got the brickwork going through all pretty good now. I'm just to the point where I can actually clean this roof off here, and just get some water and clean that roof off real good, and then I should be able to cover this all with a blanket and not have to worry about cleaning it so much. Yeah, so this is what I'm doing with the divider walls. I'm just tying them in with these corrugated wall ties, and that's the only way I can tie them in now that I'm up above the roof. I can't tie them back into the block work like I was doing before. So finally, nearing the end here, I'll just give you guys a peek. I got about 5 more courses to go on this. I think what I'm gonna do is just bump all those courses out to 1, 2, 3, 4, 5. Yeah, 5 courses. I'll probably corbel all of them out, make it look nice, and then make it a little wider at the top so it'll shed rain easier away from the chimney. Okay, I'm just getting ready to pour this top. I've parched up all the insides of all the brickwork and the divider walls as well. I've got these pieces of rebar bridging across here to help hold the lath and to hold the flues. These two flues, I'm going to be able to pour my concrete right up to them. Remember, I don't need a bond break here because the liner is going to go inside. So afterwards, when I go to put those stainless liners in, I'll just cut that wire lath out of the center and be able to send those liners through, and the top plate will sit on this. I do cut these flues kind of low because I don't want it sticking up a lot. Like the top plate ends up sticking up more, so I like to keep these kind of low so the top plates aren't sticking up a ridiculous amount. Remember, this is all getting a rain cap over it, so custom rain cap, and then the closer this is to the bottom of that rain cap, it affects the draft, so we want to keep it as low as possible. This one, I just left this insulation coming up through. I've taped around it to kind of help smooth it out a bit, and so I'm going to pour the concrete right up to this, and I've got, what do I got right here? I've got this top plate that's going to go on after, so I'm just going to pour this with concrete and then try to flatten out the concrete everywhere that this top plate's going to sit, I think, so I can get a nice tight seal on that top plate after. I usually try to put them through a flue like that, but this liner is so big that I don't have a flue big enough. Well, I have one that's way too big, and it doesn't work, so I don't have one that will work to do it like this. So I'm just going to pour the concrete right up to this and then put my top plate on after. All the concrete's on and almost done. It's just drying up still. I still have a little bit more work to do, but gotta let it set up for a while and then finish it off. Yeah, so this is what you would call a splay wash or a crown wash. Some people call it a mortar wash, which isn't really true. I don't know why you wouldn't use mortar to do any kind of top like this. Mortar doesn't last, so you'd always add Portland to it to make it into some sort of strong concrete. This stuff doesn't have aggregate in it, and trust me, it is strong enough to be up here. We're not trying to hold up another building on top of this. It doesn't have to be structural to put beams or whatever on top. So yeah, I mean, if we're going to put tens of thousands of pounds on top of it, maybe you would want to put some aggregate in it, but you can just use regular sand topping mix. I usually add a little bit of Portland to that just to make it a little stronger. It's easier to work with, and also I can just mix it up in my regular mortar mixer instead of having to bring a different concrete mixer here that can handle the aggregate. Regular mortar mixer, you can't put stones in it. It'll just bind it up. But yeah, so this is I always called it a crown wash, because you get your crown here, which is your decorative version of the top, and then your wash that goes on top. Some other people might call it different stuff, but there's been like this really strong push, or I don't know what you'd call it, but people saying that you have to have a cast in place concrete cap that extends over, whatever they go 3 inches all around, and they gotta have a drip edge underneath it. And that's the only way to do it. In some people's mind, they think that's the only way to do it, which is fine, but it's not the only way to do it. So this is perfectly acceptable by NFPA standards. So almost everybody's adopted the NFPA standards that I know of. If you're gonna have to look state by state to see what your state's adopted, but NFPA allows nice splay washes. So I think the cast in place kind of poured concrete tops to them, I think they look dumb. I don't like the way they look on a brick chimney. It just looks like a concrete block up there, when you're done. This is a little bit more subtle. and it looks more appropriate when you're driving by. But the main reason I do it like this is because what I can do now is it doesn't cost a lot of money to do this. It's maybe $100 worth of material on something this size. I don't even know. I don't know what I spent on the mix, but really it's probably not even $100. And you just need one person with trowel skills to be able to put it on. It takes you a couple hours to mix it and get it up here and get it on. The other way, you got to form it up, and just to build the form, it's going to take you like 2 or 3 hours to build a form probably, unless you have like one of the reusable forms, which are really expensive. But yeah, one person 2 or 3 hours to put it on yourself, and then you gotta mix it and pour it and come back the next day and strip the form, and hopefully everything looks good when you strip the form. But this way I can put a stainless rain cap on here, so I can do this concrete for cheap and then put a stainless rain cap on here, and that overall is going to be a much better product than just 4 inches of a 4-inch thick piece of concrete up here. Concrete absorbs water, it deteriorates, but the stainless cap doesn't. It will shed the water, and it will shed it way beyond the chimney. It has the drip edge on there, so whether charge whatever you want for the splay wash here. Say it costs $100 in material, and you want to get whatever. Even if you charged $1,000 for it, for this, and made $900 in a couple hours. Okay, so, and then you put your stainless cap on top of there, and you charge good money for that. And say you wanted to charge $2,000 for that cap, right? So say you're at $3,000 with a rain cap and the splay wash. Done. Water's not getting in at all. You're not getting raccoons in there. You're not getting squirrels down your chimney, or birds, or the chimney swifts, whatever. Nothing's going in, and you're protecting all your brickwork. If you wanted to do just a cast in place top like this, people are getting for something like this, they're getting anywhere from $3,000 to $5,000 just to do this, right? That's a lot of money. So, and it's inferior. You still would have to put individual flue tops, flue caps on, which look dumb, or you would have to put a custom cap on there, and so you're just paying a lot more money, and it's not as good of a product, in my opinion. That's why I do it like this, because all my chimneys get a custom rain cap, and I don't see a reason to do the cast in place top and then put a rain cap on it. Doesn't make sense to me. So I just dropped this top plate on here, and just marked around it with the Sharpie here, and I just took out some of the high spots so I could get this plate to sit on here roughly flat. And what I'm going to do is just drill it out in each corner and put a tap con in. I'll silicone it, and then I'll just tap con it down with silicone underneath it, and that'll be a pretty good seal. Okay, it's kind of a rain day today. We're in a little bit of a lull here, but it's going to keep raining throughout the day. It's just sprinkling now. I just got the chimney all washed. It did take a while. This smooth face brick ends up getting pretty dirty. This is what I came up with for the outside air to control this little flap down there. That's all the way closed. That's all the way open. That will stay there. Just like that. Okay, so I was able to get this liner in. I just finished up putting this high temp mortar in here. It's like the high temp silicone I used before, but it actually resists a lot higher temperature, and it seems to be a lot better. I've been using it since last year, and it works pretty good. Easy to clean up. It's just this high heat mortar. It's good for 2,000 degrees. It's good for putting pipes together. It's pretty cheap stuff. It's not near as expensive as that high temp silicone. It seems to work better, lasts longer. Yeah, so now you can see why I have this coming out at an angle here, because this one is going over to this furnace. Obviously, I'm going to put 2 new pipes on there, and then that one's going to come out and turn and kind of face this direction. So I'm just getting this liner set up, and you know, the first thing I do is go inside and measure for my clean out and where my thimble's going to go. So basically what I do is I measure bottom of the opening to bottom of opening. So this will be the very bottom of my clean out, so the block work, the very bottom to the very bottom of where my thimble hole is. So usually it's block in the basement, so it's block height, so the very bottom of that opening, if that makes sense. The very top of that block that my thimble will go on top of. So bottom to bottom, and then I do the same thing here. I measure bottom to bottom. I measure from this bottom lip to this bottom lip, okay? I know it's 40 inches, so I usually hang back a ½ inch. And then when I put this liner in, when I screw the liner on, I'll stay down from this lip about a ½ inch. And that'll put me at 40 inches, and then I'll be really close on my openings. All right, I've got everything together now. So yeah, I got 3 screws in every connection. You don't just use the clamps, you got to still have screws in there. So I use the clamps just to temporarily hold it while I put the screws in. So 3 in every connection, there, and then at the bottom. And then you try to roughly line up that with that. It's not critical because you can still twist this stuff. There's a little bit of twist in it, so you can align it in the basement however it works out. So now I'm just using some of this high heat mortar to put on this seam here. So there's 3 seams here to do. So I'll do this one on the inside, and then the one at the bottom down there. And I do that on all of them. These ones fit pretty tight, so you might think that you don't need it, but it doesn't take long, and I think it's worth doing it just to make sure everything's sealed out of it and there's no air escaping from the system at all. It's cheap enough. I think I paid like $7 a tube for this stuff on Amazon. Just got that to do, and then I can put the insulation on here and get it ready to go up. And so the clean out, a lot of you think, a lot of people will just take and put their end cap. This is an end cap right here. They'll run the liner and just put 1 T-body, 1 end cap, and it's a really easy install, but you need a clean out door. I always put a clean out access, and most people don't know that you need a clean out access because they've never built a chimney or a fireplace. But if you read any kind of standard on building chimneys and fireplaces, they all require a clean out access, which makes perfect sense. Like if you have an appliance, you ought to be able to clean it out. If a bird falls in there or a squirrel falls in, you ought to be able to open the door and grab it out. If you have a chimney fire, the fire department ought to be able to access without taking the whole stove off. Imagine being able to open a door and spray a fire extinguisher up there or something. It would make a big difference. It just makes all the sense in the world. You'll never see me put one together without a clean out access, and it would have to be the rarest of circumstance where I didn't have a clean out access. You can do it on pretty much everything. It's just a cheap, lazy way to do it with just 1 T-body and no clean out access. And I know there's more people that install it like that with just one 1 T-body than there are that do it with the clean out doors. But because people buy a kit and the kit comes with 1 T-body, and they think, oh well, if they put this kit together, it must be code to do that. It's not. Because I'm going to have insulation around this liner, I'm going to have a really hard time getting the band for the snout around this. So what I like to do is take a piece of masonry line or rebar tie wire or something, and I'll just tie this together and I'll stuff it inside here. I'll wrap the insulation over, but when it gets in the chimney, I know that I'll have a piece of rope or something to grab hold of, and I can tape that to the band and just pull the band right around, because that insulation is going to be tight on here, and then I'll be able to pull that band right around. If you didn't do that, you'd have a really tough time trying to get the band around. All right, next step, I'm going to use some of this spray adhesive to spray this liner. I'm going to spray it right down, and then I'll wrap this insulation onto it and it'll stick. And then I'll grab my foil tape there and tape it together, and then tape the long seam down. And after that, I got this wire mesh tube that goes on. It's going to be a pain to put that on myself, but I hate putting this stuff on, to be honest. But it's not difficult. It's just a pain. And then I got a couple clamps to hold it top and bottom. Yeah, so it's not really hard work. It's just, you know, that particular part is a pain. The rest of it's pretty easy. There you have it. It's wrapped. So now you notice all this stuff hanging over here, right? It's the same. They give you the same size wrap for a 7-inch liner that they do for an 8-inch. So you've got all this excess on here. And if you don't have the room in the chimney, you really ought to cut it off. It'll make it install a little bit easier, because that does build quite a bit of thickness. So I'm going to get a fresh blade on my knife and I'm going to rip that off. I'll do a nice job cutting it, and then I'll tape that seam right up. And it will have less build. You want to wrap this insulation as tight as you can and have everything as tight as you can. Otherwise, you know, it could potentially bunch up in the chimney while you're trying to install it and just be a pain. Of course, it's raining again. I just got this tape on in the nick of time. This year's just been extra miserable. You know, coming out of winter, it's just been super depressing. You know, it's rain every day. My kids probably played, their baseball season's done now. They've played like 2 games in the sunshine. It's been awful. It's hard to get motivated in weather like this, you know. Yeah, so this is just a tube, right? And it opens up like that, and you slide it down over. I like to just tape up the end of the insulation here, just so it doesn't catch and tear up the insulation as it comes on. You do want to wear gloves with this stuff, just because, you know, it'll actually cut you open. It's all stainless mesh. It's like a chainmail pattern, and it will cut you. So most of this stuff will cut you. Actually, the stainless liner will, the tape will, the edge of the insulation will. I wear gloves as much as I can doing anything with this stuff. Yes, I'm gonna get this tube on. I'll put I got these clamps, so there you go. Just clamp it, one at the top, one at the bottom, and then it's gonna go up and in. Maybe I'll set up the camera so you can watch my misery as I try to drag this thing up that ladder by myself. This is what it looks like with that stainless mesh on there. You see, it is on there a little bit loose, because this stuff is made for an 8-inch liner as well. So, but really the only reason this stuff is on there is because this insulation will get all tore up just trying to do the install. So it seems like it's pretty much on there for just the install going down inside the chimney. Otherwise it would get tore up and that insulation would be peeling out everywhere. So this stuff actually does a really great job of protecting it on the install. And I do recommend wearing long sleeves when you do handle this, because it'll tear your skin up like a cheese grater on it, you know, if you slip, or when you're pulling up the ladder or whatever, you know. Okay, so this is where we are. I felt from the top that I hit something pretty solid. It does work nice when there's two people. If there was two people with me, I'd have someone go up top and lift this while I try to, just push this back in, but look at that. Anything will catch on the way down if you let it. I tried to cut it so it wasn't sticking out, but it still stuck out enough to catch. Anyhow, so I'm gonna have to just try to muscle this from here. I'll lift it and push it back and then let it drop down. Okay, so I just got this cut open here. Cut the mesh off, cut the insulation off. And now I'm gonna try to pull this around. I've just got a, piece of masonry line tied on and taped on, and now I should be able to just pull this real slow. Hopefully it will stay up against the metal and not get into the insulation, and pull it right around. Oh, darn. Okay, so here we go. I'm going to push and pull at the same time. There you have it. Just thinking ahead makes it much easier. Okay, I got all this pipe made up. Got that one made up. It's gonna go from here over the top. I'm just getting ready to, everything's pretty much finalized. Getting ready to mud this stuff in and, brick and block that in and that in. The one thing I gotta do first is I'm gonna pull a piece of this. Now that I have all the pipe screwed together and I know it's not pivoting or it's exactly where I want it, now I can put that inline damper in. I'm just gonna probably pop this elbow and put that damper in right here where it's easily accessible. I had to make sure there was enough room to still open this panel up here. I didn't want the pipe to be right up against there because you wouldn't be able to pull this panel off and on to service it. I got all the pipe on now, and everything's just kind of mudded in and bricked in. It's not so pretty right now, but what I'm going to do next is mix up some rapid set mortar to go on the outside of all this stuff. Notice that everything's just recessed a little bit. I'll go over that with the rapid set and I'll probably try to make everything just look like a block, that way when the rest of it's painted. So if I make it look like a block and join it up, then it will blend in. Just wrapping up in here. Just finished cleaning everything up, and this is what it looks like. The lighting's not the best, but everything kind of looking like a block here. And so if somebody wants to come back and paint it, everything will blend and look like block work. Just got these liners cut off at the top. And mounted down like this one I had mentioned before. I was going to put some tap cons in it to hold it down. Got some silicone all around it, weatherproofing it. I'll cut off this excess tomorrow when I get here after it dries. Those are silicone down to the flues and got screws in the top of all of them. These are all my custom low pro top plates. I special order these. I stopped using the other top plates because they have these humongous holes between, you know, the liner and the top plate. And these ones, it's a lot less. It just tends to work out a lot better. It does, you know, it looks like it's a gap, but it's really not that bad at all. The other ones, like I could put my whole finger in there. They were getting a bit ridiculous, so I like these ones better because they don't stick up as high either. You know, you just put the 3 screws in it and you're fine, and it's a lot lower. You don't see it like as much from, you know, from way out there on the ground or driving by on the road. So I really like these top plates they've been making for me. I'm finally up here doing the flashing. I had my buddy that does metal roofing. They do commercial metal roofing, and so I had him hook me up with a piece of bent metal here. Just one piece of bent metal, and I cut the extra pieces I needed off of it. I usually don't bend up metal like this, but I'm giving it a shot here. It seems pretty easy. The one thing about metal is it's not like lead where it's malleable and you can like bend it around corners. You know, this stuff always kind of has like little pinholes on the corners that you can't quite get out. Yeah, so I've just bent up all this stuff in my own way. I'm sure somebody will say it's wrong. This is not something I typically do. Don't do metal roofing. So I just talked to my buddy, you know, about how I should do it in this particular circumstance. And, you know, he bent me the metal and he gave me this butyl tape to put down because of how this is going to go on here, and some fasteners to match. I've just kind of, you know, bent up all this stuff how I saw fit. I don't know if this is how somebody else would bend it, but I think it's going to work pretty good. I've got all this zip tape on here. Keep in mind I did bend this flange up here. Obviously it didn't bend right to the corner because, you know, that's the thing about metal, is it's always got those pinholes to worry about. But this zip tape seems to hold really well, hold on the metal and the masonry. So that's going to be under there, and this is pretty much watertight just with the zip on it, unless we got like a torrential rain and the brick got saturated and the water seeped in behind it, then it would get in. But yeah, I think it's going to work pretty good. So I'm going to put all this metal down, and then I'm going to have my lead. I'm going to cut all the lead into the brickwork after. Yeah, so I'm going to start by putting this butyl tape down, and then I'm going to put everything in place and screw it down, and then I can mark out my lead and start cutting my lead. Okay, I've got all this bottom flashing in and screwed down. I did mess up a little bit. I left the plastic on after I put it on the butyl tape and screwed it down. I should have ripped that plastic off before, so I have this little kind of nasty plastic edge that I'm gonna leave on like that. But I think what I'm gonna do is just hit it with my torch just for a second and just kind of melt it out of there so you can't see it. Yeah, so I mean, I'm not used to dealing with this type of metal, so accidents will happen, I guess. It's not so bad. I got all the flashing marked out, and as you can see, there's multiple lines here. I do make mistakes. Yeah, so I tried to start off that corner of the brick and strike the line out, and it just didn't work out. So I ended up having to go higher and higher because of just some of the chip brick that I put in. You see that chip brick right there. The lead flashing wasn't going to cover that chip brick. So, you know, there was a bunch of bad brick in this lot. I probably lost 30% of the brick that I bought because the faces were just like, you know, broken off like this. You know, chip, crack, broken off, and it's just shipping. They're all Pine Hall brick, and you know, they look decent, but they were a little chippy, so I lost a lot of brick. So I put some of the broken brick on the back here, not worrying about it, but you know, I wanted to make sure that my lead was going to cover that. So I ended up going higher and higher till finally I got beyond it. So then I struck this line here. That top line is the one I'm going with. And you see everywhere that this line will intersect the motor joint, I just take my Sharpie and I just draw a line down like that. And I know that's where my flashing is going to start. You know, that piece will start there. And so that's where I'll start my cut. And then I know I'm going to use 10-inch flashing because I can see that from this line here to this line here, I'm going to get 4 inches of coverage using 10 inches 10-inch wide flashing. So that's what I'm looking for, is 4 inches. So I put a line here, and then I put a line here. And matter of fact, that line's not even, I should draw that on there a little better, because usually what I do is, see that line, I draw a line. That's 10 inches. I just measure over as I go, 10 inches, 10 inches. And then I know where my cut is gonna stop. So I'll see this line as I'm cutting, and I'll just overcut that slightly on either side. Yeah. So now I just got to cut this out, and I've got all my measurements already. That's the nice part about doing the flashing like this afterwards. You get a nice consistent look to it. And also I can just measure everything and snap a picture and go down, and I'm going to cut all this stuff on the ground. So, you know, all these pieces, the main run, it's all going to be the same size. So I need 12 pieces of the 10-inch flashing at 15.5 inches. And then, you know, a couple other ones. This one's the very bottom, and that one's going to be the very top. So it makes it really easy to do flashing if you do it afterwards, and it looks better. So all the flashing is installed now, and I just have one last step here, and I don't want to just leave all this stuff hanging loose, you know, where the wind could blow it apart, you know, away from the chimney, or, you know, something could happen to it. So what I want to do is I've got my line struck, and I just measured 3.5 off the chimney, because that's kind of what worked here. And so I strike my line up straight 3.5 all the way to the top, and then everywhere where this next piece of flashing comes down, I mark it like this, and that's where I'll cut. I'm going to cut this, and then I'll kick them out at an angle like that all the way up. And then that will leave me just that little triangle piece to overlap onto the piece of flashing above it. And I'll show you what that looks like when I'm all done. Okay, the flashing is all bent up, and now it's completely done. So you see how I just tuck this stuff around each other, and I leave these tabs on to bend over. Now this is all one piece, you know. What happens over time is, you know, some of these pieces will start to pull away from the next piece, and then you get bats in there, or like, you know, tree frogs and other insects or whatever. Hornets will build nests in there. So you really want it to be all together, so they can't just pull out one piece, or the wind can't pull out one piece and let critters in there. So a critical mistake that a lot of people make is siliconing this stuff down to the metal, and you cannot have this lead adhered to the metal on the roof. Or, you know, it's two different metals. They expand and contract at different rates, and what will happen is this lead will just wear out over time because of the fluctuation in temperature. That roof is rapidly expanding and contracting, and so isn't this lead, but at different rates. And what happens is when you fix it to the roof, it will wear a hole through the lead. So we never want to fix it to the roof, and it is a mistake that a lot of people make. Even the guy that did this roof a couple years ago, he made that mistake by siliconing the lead down as well. Never silicone the lead down to the roof, or adhere it in any way. Screw it down, nail it down, nothing. And this is what the top looks like. Just like that, everything's locked together. Remember, we have the butyl under here, so no water can get in. That butyl is super sticky stuff. It's really unforgiving. If you mess up putting it down, good luck. yeah, so I think it looks pretty clean, looks good. If you are wondering, there is silicone in there. A lot of people will comment saying, oh, you need to put silicone in there or something in there, right? Anyhow, yeah, that's it. So now I get to take this stuff off the roof and get it in the truck.